Hello everyone and welcome on today's video. My name is Wouter Peer and I'm the founder and main developer of GG2 Cloud. And today we will be ending our discussion on the topic which one is better, the single or the W tube. Because, as we discussed the last two times, this is exactly one of the most frequent asked questions in perhaps the whole of shallow geothermal engineering field. Which one is better, the W or the single U? And in the last 2 weeks, we already talked about the thermal aspects related to this question, the borehole effective thermal resistance, and we saw that it depends quite a lot on which flow rate you have, which grout thermal conductivity even, so you had to simulate your own particular situation. Now for the hydraulic aspects, there was a little bit more general information I would say you can get, namely that having a single U from the same diameter as a W will always give you worse hydraulic performance. But again, there, if you want to compare it also with the thermal side of things, you have to simulate. There is no general conclusion to be drawn. And today in our third part, we want to talk about some practical aspects. What are the advantages or disadvantages from having a single over W tube? And we will be also talking about some special probes, innovative designs like the Separatus, like the TurboCollector and the GEROtherm VARIO and FLUX probes. But let us start with the practical aspects. So, why do drillers often prefer single U probes? And it's because they are cheaper. And they are cheaper because, well, instead of having two probes, you have only one. So there is less material and less antifreeze needed, which saves you costs. Also, because you now only have one pipe instead of two, you don't need as much counterbalance weight. So in order for the pipes to stay at the bottom of the borehole, you need some weights to pull them down, and if you have a single U probe, you only need half of this weight. So that also saves you cost. And because you now only have two pipes, or two ends coming out instead of four, you don't need as much weldings for the horizontal connections, you don't need as much horizontal connections also, so there are less risks for leaks, which is also in the end a cost saving because it's a certainty or a higher certainty. Single U probes are also faster to install and also easier to install, and that's because you have a certain borehole, and instead of putting two probes in it, you only need to install one, which makes it easier because there is more space in the borehole. So the pipes go down easier because there is less friction. This means there is faster, and there is also less risk involved because the faster you get these probes in the bottom of your borehole, the less risk there is that your borehole collapses, especially when working with loose sands or clays, etc., and rather deep boreholes. And because we have more space in the borehole, it's also easier to backfill them, because if you have a W probe, it's sometimes harder for the ground to really get to the top of the borehole, and when you have a single U, it's easier to do so. So from a practical point of view, we can say for sure that a single U probe is preferred. It's easy to install and it's oftentimes cheaper. Now, this was for the practical aspects. Let us now talk a little bit about some innovative products. And I've listed them all here. So we have a Swiss product which is called Separatus, which is basically a DN50 probe in which they put a membrane to separate the cold from the hot liquids. So instead of having a U tube, it's just one pipe that goes down. So it's even easier to install. In the middle, we have an image from the TurboCollector from Movitech. It's our traditional smooth pipe in which they installed rotating and counter-rotating fins in order to enhance the turbulence at a lower flow rate. And to the right, we have our conical probes, the GEROtherm VARIO and FLUX probes from GEROdur, where they were designed for deeper boreholes, where the pressure drop becomes significant. And here they have made it such that the wall thickness varies over the depth in order to make sure that you get the lowest hydraulic resistance. If you have not watched our videos on these probes, we have one for each of them and they are linked in the description below. But let's go over them one by one, starting from the Separatus. Now here you see our graph, which we already discussed in our first video of the effective borehole resistance and function of the flow rate. You see our traditional single U probe and our W probe, where we see that, just as we discussed earlier, that there is a range in which our single U outperforms our W because we're already in the turbulent regime and the double one is not. Now, as you can see, the cutoff point where the turbulence starts is around, let's say, 0.2 liters per second. For the Separatus, it's somewhat later because the inner diameter is a little bit larger, so the turbulence is achieved a little bit later. But you can see that in this case, the Separatus always performs worse. And you can clearly see that based on the graph below, which is a cross-section of a 140 millimeter borehole with the Separatus in between. And as you can see, there is quite a lot of grout resistance here, leading to a worse thermal behavior. Now, if we look at the hydraulic point of view, you see that our W is, as we discussed earlier, the most beneficial. Then we have our Separatus and then we have our single. So our Separatus is better than our single probe, single DN32. It has a lower pressure drop since the inner diameter is also a little bit bigger. Now, let us compare this to a situation where the Separatus was actually designed for. Because the idea behind the Separatus was that since you have a smaller pipe, you can also drill with a smaller diameter. So here we have now a diameter of 90 millimeters, and as you can see, the probe relative to the pipe diameter is now bigger and it's way closer. And what you can see here is our red line, which is identical to the green one, but it's shifted to the bottom of the graph because we're now having less grout resistance. And as you can see, there is even a range now in which our Separatus, given this smaller diameter, where it outperforms every other solution. So where the Separatus is better than our W tube, not from a hydraulic point of view, but it is better than a single DN32 from a hydraulic perspective. So when we're talking about Separatus probes, it's really important to take this borehole diameter into account because that also plays an effect. Now, if we now look at our second solution, or the second special probe, which was the TurboCollector from Movitech, we have our same graph where we had our double DN32, we have our single DN32 with this overlap. And as we said and discussed earlier, what the TurboCollector does is it enhances the turbulent flow at a lower flow rate. So instead of transitioning towards a turbulent regime at 2300 Reynolds number, if you have not watched our video on the Reynolds number, it's linked in the description. But the TurboCollector decreases this limit or this threshold from 2300 to 1800, meaning that you get a certain range, you increase the window in which your single pipe outperforms the double pipe. And what is interesting, if we take a look at the pressure side of things, is that our pressure drop is more or less equal to our single DN32, so without the fins, except in this small region around 0.2 liters per second, where exactly our TurboCollector is already turbulent. We see that the pressure drop is also slightly higher. Now, what is interesting, for example, as we discussed in our last video, we can also combine or compare the double DN32 with a single DN40. And by increasing the pipe diameter, we can decrease the pressure drop, which is exactly what we see here. So we have now our single TurboCollector DN40, which is the red line. And what you can see is that it is better than our single probe. Yeah, because of course we now have a DN40, which is a larger surface area, so it can exchange heat easier. But since we now have a bigger diameter, it's a little bit harder to get into turbulence, let's say. And that's why we can see that we lose a little bit of window where our single pipe is better than a double pipe. But from, let's say, 0.2 to 0.45, our single TurboCollector DN40 is still better than a double solution. And what is interesting is, since we are now working with a bigger diameter, our pressure drop is also significantly lower than the single DN32 counterpart. So for this situation, depending on your flow rate, etc., you could argue that it is beneficial to switch to larger pipe diameter, and due to the turbo effect, you can also get a good effective borehole thermal resistance even at these lower flow rates. So that's the story for the TurboCollector. Now for our last special probe, the GEROtherm VARIO or VARIO probe, we will switch a couple of assumptions because our previous simulations were all for boreholes of 100 meter to make it easy. Now these GEROtherm VARIO and VARIO probes were actually designed for way deeper boreholes, 200 to 500 meters. So we will now work with 350 meters deep. We'll also increase the borehole diameter to keep it a little bit more realistic. And the pressure class is now not 16 but 32 PN. So if you take a look at the borehole thermal resistance for this flux probe, you see that due to the fact that our boreholes are way longer, we have more this, how should I say it, this general slope going down. And you clearly see also the transition from laminar to turbulent for a single DN40 now, because we're working with longer pipes, deeper boreholes. We increased the diameter to DN40. So for a single, the transition between laminar and turbulent occurs around 0.2. For the double, it occurs around 0.45. But for the flux probe, which has this conical design, you see two cutoff points or two break points. That the first one is where the conical region starts to becoming turbulent, and the third one, or the second one at 0.3 liters per second, is when the last part of our conical probe is also turbulent. So that's why we see 2 points here. And what you can see is that there again is a certain region in which our single DN43 probe outperforms the other two. Now if you take a look at the pressure side, we see some interesting facts, namely that we are better here, and we have a pressure drop which is more or less the same as our double situation. And that's because the conical design makes it such that we can actually optimize the pressure drop for design. Now we can do the same exercise we did with the TurboCollector. Let's now, instead of using a single flux of 43 millimeters, let's use one from 53, because the higher the inner diameter, the larger the inner diameter, the lower the pressure drop will be. And here you see the red line occurring, and as you can see, it transitions to turbulence later at a higher flow rate, because now our inner diameter is higher, so we need more flow to get to this turbulent regime. But what you can see is that we approach almost, it's a little bit higher, but it's very, very close to our double DN40 design. But if we take our pressure drop, we see that our red line, our single flux DN53, is actually, which is interesting, better from both a thermal perspective, then the orange line is a double DN40 and we have here our single DN53. It's better from a thermal point of view and a hydraulic point of view. So in this case, which was not for our other solutions, we have again found a flow range in which our single probe outperforms a double one, both on the thermal and the hydraulic viewpoint, which is really interesting. So I want to end this series with, and I again call it current conclusion because this is again from a different viewpoint, to the question double U-tube or single U-tube, which one is better? From a practical viewpoint, we say, well, the single U-tube is always preferable, it's cheaper, it's easier to install, less risk involved. But when it comes to the special probes, the Separatus, the TurboCollector, or the GEROtherm VARIO and FLUX, the answer is you really have to simulate your specific situation. Because depending on your pipe diameter, depending on your flow rate, depending on your depth when it comes down to the conical design, so your borehole diameter when it comes down to the Separatus, it's really important to take all these aspects into account in order to be able to answer this question for your particular project. Because for your situation, there will be a solution, but there is not one in general. And I hope that in this 3-part series, we gave you some insights in how you can reason about this problem. Perhaps we forgot some other aspects of some other cases in which one probe or another performs better or worse. That's totally plausible, and if you find some, please send them to us. Perhaps we can create another part of this series with even more nuance, which would be very interesting. And if you thought this was interesting, please consider subscribing or sharing it with your colleagues. And I'm looking forward to seeing you in our next video, in our next discussion. So take care. Bye.